A pleasure today to have in studio two guests talking about today's topic. First of all, Craig Rigby is Vice President of Technology at Clarios. And joining us also is Chris Robinson, who is a Senior Analyst at Lux Research. Gentlemen, thank you both for being with us in studio today.
Thanks for having us.
Yeah, thanks.
Craig, let's start with you and a bit of an overview about Clarios' role right now in working with OEMs or automakers about the future of mobility, not just electrical powered cars, not just self-driving vehicles, but again, mobility encapsulates so much more.
Sure. So Clarios has been working with automotive OEMs for decades in providing automotive battery solutions to support their electrical needs in the vehicle. And what's happened in the last decade has been a really radical transformation in terms of the role that batteries play. And the obvious part of that is electrification through EVs and hybrids, and we've been part of that as well. But even with the 12-volt batteries that you think of as the batteries that you start your car or power the lights when you turn your key off and all that, even the role for those batteries has changed really dramatically with the advent of technologies like start-stop, which is a pretty low level of electrification, but has massively been adopted throughout the globe over the last 10 years, all the way through now the role that a 12-volt battery plays in high-voltage hybrids or EVs. And then with the onset of autonomous vehicles, power consumption in the vehicle is going up. All the sensors, all the processing, all the actuators related to autonomous are consuming more power in the car. So the role of the electrical system, the role of the power supply has been accentuated and putting new requirements in terms of reliability, safety, critical functions. All of those things are forcing us to rethink the way we approach battery technology in the car and how we collaborate with our customers on that.
And what's a basic overview right now, Craig, of the capabilities of an in-car battery as we know them?
Right. So with respect to 12-volt batteries that hold down that 12-volt power net in the car, which is still there, it still will be there, we think, over the coming decades, the shift has been away from an emphasis on starting the engine, on a cold day, to making sure that there's no way the power can drop off. So if there's fluctuations in alternators or fluctuations in a high voltage battery providing power, that 12-volt battery has to be the last stand, if you will, of power in the car. So thinking about it in those terms, making the product as simple as possible to remove failure modes, but as reliable as possible and having it be robust to temperature, operating environment, any of those sorts of things is something that we've done well, but we need to do even better going forward.
Chris, probably appropriate right now to start this side of the conversation with the 30,000-foot view of where the sector is right now. What are we seeing on the road right now? Not a prediction about tomorrow or 5 years or 15 years, but today where the industry stands.
Yeah, I think when we look at something like vehicle electrification, there are kind of two sides to the equation. Yes, there's a lot of excitement around electric vehicles, and the capability of those vehicles is really impressive in terms of the advancements in range, reductions in cost. But we're also seeing a lot of activity within electrification where consumers might not even be aware. Kind of more robust hybrid systems that allow for more features, maybe a more robust stop-start, maybe other types of features that can increase fuel efficiency. And that's where I think a lot of the volume of the automotive industry is going. Not to say electric vehicles don't have a future. They've certainly grown very quickly in terms of market share and the numbers sold. But I think it's worth also noting there's a lot happening in these kind of lower voltage electrifications that can save the old internal combustion engine, make it incredibly more efficient.
What's the level of, and I'm not talking in objective terms, much more subjective now, but the level of consumer awareness, understanding, appreciation of the industry right now and the applications that we as drivers can take advantage of?
Mm-hmm. Yeah, I think a lot of consumers are maybe excited and skeptical about things like electric vehicles. Certainly it's a quieter ride, it's more efficient, but of course consumers are concerned about things like range. What happens if you're in an area where your vehicle might run out of power and you don't have access to a charger?
So range anxiety.
Range anxiety. But there's also charge time trauma is another term, right? If you want to take a road trip, how fast can your car actually charge back up? do you need to stop for an hour every few hours in a road trip to actually charge that vehicle? So there are some practical limitations that even if it's something that only comes up maybe once or twice a year, it's still, cars are a big investment and consumers are concerned about that.
Yeah. Craig, staying with the theme of today as a distinct moment in time, the latest technologies, the latest components that are required right now for where we are and where we're looking immediately ahead for EVs, for SDVs. What's in place and what's immediately on the way?
Well, I think there's two branches, and I'm going to speak really primarily from the battery perspective, because batteries are really an enabling technology for all of these applications. Obviously, there continues to be significant development in lithium-ion battery technology, and Chris mentioned, the increase in range, and there has been significant improvement in the rechargeability of that technology. And I think we continue to see more advancements. I think it's great, for instance, that the Nobel Prize was awarded to chemists and engineers who developed lithium-ion battery chemistry. But I think we also have to be practical, and you can put that in context that work happened 40 years ago. They're getting recognized now. The time frame for this technology and how fast it can mature is not as fast as maybe we'd like, and we have to be sort of pragmatic about that. The idea that there's a Moore's law for batteries it's just not true. That said, we do anticipate new technologies will continue to increase the range of the vehicle, or decrease the charge time of the vehicle. At the same time, there's another layer of battery technology that's happening that probably you wouldn't think about as much. And in thinking about 12-volt batteries I was mentioning earlier, we've seen a migration from the standard flooded lead-acid batteries that were everywhere in every car 10, 15, 20 years ago for decades. And we've seen a migration to more advanced lead-acid battery technologies like AGM, which stands for absorbent glass mat technology, which is a much more robust battery technology, more capable of cycling. And that's been a key enabler, for instance, to start-stop technology, which gets you 5-6% improvement on fuel economy, but goes on tens of millions of vehicles around the world every year. As we think about high-voltage EVs, or even start thinking about autonomous vehicles, having that most robust technology that's capable of operating in all kinds of duty cycles and in all kinds of environments, like AGM, we believe is going to be a key component to continuing to hold down that 12-volt network.
So staying with 12-volt for a moment, since that's so easily identifiable and easily associated with today's current car technology for drivers, as you alluded to earlier, Craig, the demands on a battery moving forward are growing year by year just because of the connectivity.
Yeah,
maybe the right way to put it, and all the sensorization that's involved in that. How do you address that from a battery technology point of view? That demands are getting higher and higher, but in essence, the space allotted to a battery in any vehicle is not
right.
growing.
It doesn't really grow, right?
in a fair proportion to the demands placed on that.
Yeah, that's a great question, and I think in terms of the demands, just to put some quantification around that, because I think it's useful, is even in the most sophisticated, the most luxurious cars today, if you start automating those cars and you get to the vision that most people would think, which is an autopilot function getting you around a crowded city, when you get to that, you're at least doubling the amount of electrical loads in the car based on the sensors, but really based on the processing power required to manage all that information and make real-time decisions. So if you think about how much more power is being consumed in that process, not just the amount of power, but the criticality of that, because those computers can't drop out. You can't just have a reboot happen in the middle of a drive cycle, because that has massive consequences if you're in autonomous mode.
Right, or any latency whatsoever.
Right. You can't have those delays. And the systems are being designed to be as tolerant as possible, but ultimately the bottom line is you need to have reliable power. Now, so you've increased the loads, you've increased the sort of criticality of managing power. You need to have power supplies and batteries that are incredibly robust. And so to contrast that a little bit with the way when I was younger, when I was getting my first car, the way I would have thought about a battery is the most important thing it had to do was start the engine on a very cold Michigan day. and if it didn't do that, that was a pretty big inconvenience. Yeah. But it's a lot different than if you have a disruption when you're autonomously driving around New York City. the way that battery was used 30 years ago was essentially keep it charged all the time. It never drops below, and it will always do what you need it to do. That's not the way these batteries are being used today. A lot more of the batteries being used, whether it's for efficiency's sake or to manage power in the car. And because of that, you can't use the same technology you used 30, 40 years ago. You have to use the best, most capable technologies we have. And we're going to continue to push to make them even better.
So, Chris, what lies ahead for 12-volt itself then, if demand's growing so quickly and so broadly? Is the capability of a 12-volt battery outstripped? Does it still have a future in the car?
Oh, absolutely. I think so. I mean, the other angle to think about this from is there's so many components in the vehicle, like the radio, the windows. I mean, all of this stuff comes from 12-volt power sources, and I don't think anyone wants the idea of a power window being powered by a high-voltage battery. That would be a pretty alarming experience if there were any electrical issues and you had shocked. And I think that really the criticality of a lot of those components and the fact that cars are designed today for 12-volt means that really a lot of those components are here to stay. I think one interesting fact that maybe a lot of people don't know are a lot of electric vehicles, like Teslas, et cetera, they have a 12-volt lead-acid battery in them, powering a lot of those components. In even something like a full electric vehicle, when it's shut off, essentially that high-voltage battery is completely disconnected. Mm-hmm. So you need a battery to boot the computers, to actually connect the high-voltage battery and get that system started. So in a way, really the beginning of lead-acid batteries, starting a car on a cold day, kind of coming full circle that 12-volt battery needs to turn the car on, essentially.
Mm-hmm. How quickly does this side-by-side performance become commonplace in the market?
Sorry, side-by-side performance?
Sorry, let me try that again. What I meant is the high voltage, or LIO, and then the 12-volt. So you're saying they're working together, right? Mm-hmm. That's all. Is that a fair question? I can also phrase it any other way you'd prefer. Is there a better way to say it?
I think it's a very fair question. You might phrase it. We're talking about in terms of multi-battery systems.
Yeah.
And the fact that they are independent, yet they work together.
Yes.
So however you want to phrase that.
That's a fine way. Yeah, okay. Multi-battery system.
Yeah.
Okay. Yeah, basically state of play of where that is right now versus where it needs to be.
Craig, this may be a better question for you, I think.
Yeah. So we've been.
Is that comfortable for you?
Yeah. No. It's totally comfortable.
Let's go ahead and jump in with just that then. Okay. Chris, it's okay with you? All right. Let's do that. I'll pick it up again. So, Craig, back to you. What is the current state of play for multi-battery systems? I mean, Chris just outlined why you need different batteries for different functions within a car. Where are we right now, and how does that change?
Yeah, it's a great question. And the reality is we're well into that process of looking at vehicles and seeing vehicles on the road with multi-battery systems. And I think if you think about that, it's as simple as, well, yeah, if you have more than one battery, you have multi-batteries. But the way they work together, I think, is really critical. In a full EV, the large lithium-ion battery, it is the power source for the vehicle once you've charged it. And as Chris said, though, when that car is shut off, that battery is disconnected. It's not active at all. Mm-hmm. All the power you're going to get for your computers, for your radio, for your lights, all of that's coming from a 12-volt source. And in fact, the 12-volt source, as Chris mentioned, is responsible for actually starting that high-voltage battery. Another example is in cars that are probably not as obviously electrified, but are hitting the market today, mild hybrids, usually operating around 48 volts. Mm-hmm. These are vehicles that get a lot of the benefit you would get from a full hybrid like a Prius, for example, but you get them at a lower cost point because, frankly, the technology package isn't quite as big or as expensive as it would be with a high-voltage vehicle. In that case, you have a 12-volt battery, typically lead-acid, and a 48-volt battery, typically lithium-ion, working together to manage the power in the vehicle. And it's very much a collaborative thing. And if you look at state diagrams about how these batteries are functioning, what they're doing at any given time, and this is the kind of work we do at Clarios. We'll instrument vehicles, we'll analyze how they're working, how the batteries are working together. You see a very active collaboration around how power is being managed between two networks, a 48-volt network and a 12-volt network, mm-hmm. and two different battery technologies. And the fact that they're two technologies actually plays as a benefit, I think, from an engineering perspective, because, different failure modes, different risk factors, and they're complementary. One does things certainly very well in terms of very fast charge with lithium ion. The other one is extremely reliable and simple, like lead acid. Those two things are very complementary.
Craig, you brought up an interesting point earlier, and that is the fact that any kind of battery, I'll say failure, but it could be just a hiccup, for to use a layman's term, carries much greater consequences when you're going deeper into self-driving vehicles.
Sure.
What is Clarios' overall role in that? The idea of power solutions and ensuring that doesn't happen,
Right.
Front-end managing that before fleets are widely implemented on the road and these problems arise.
That's a great question. And I think one of the things you have to consider with autonomous vehicles, whether that's fully autonomous or even sort of levels of autonomy approaching that, I think every automaker is going to have some particular view of how they want to manage the risk of failure. And there's some guidance there in the industry around standards about that process, but there is no given solution. There's no defined way in terms of how you do that. So every automaker has their own philosophy about how to manage failures, and that's what we're really talking about here. If that high voltage lithium ion battery fails in some way, typically what that will trigger is that battery being disconnected from the vehicle. And that can be to a loss of communication, it can be to a detected short circuit, or somehow something happening where that battery's at risk. One of the responses can be disconnecting that battery. And that's not desirable, and it's very not going to be very common, but it likely will and can happen. In that case, because it is the only power source in that car, you've now disconnected that, and you still have to have power to manage the computers, to manage, for instance, steering systems, which are all electrified now, braking systems, which are electrically actuated. All of that cannot just stop. It can't be turned off simply because the high voltage battery is no longer connected to the car. At that point, the only power source in the car is the 12-volt battery. That 12-volt power net cannot see any sort of brownouts. It's almost like running a data center, where if you lose power to your data center, you can't afford to have all those servers go offline. You need to have that power backup that bridges that period of time. The 12-volt battery essentially is performing that kind of function until that car can be safely taken out of autonomous mode and navigated to the side of the road and then call for service.
I'm not in the business of coining phrases, but it sounds like proactive redundancy, and I'm pulling that out of thin air, right? But you have that backup, and yet that 12-volt is not only a second teamer; it's doing active functions throughout the time that you're driving.
Right. That's very true, and it's not right. It's not sitting there waiting to do something if something should fail. It is an active participant in the vehicle during the drive cycle, but it does have that sort of last stand function of if everything else goes wrong, there still needs to be power in the car, and that would be the last point of power.
Chris, what's the road ahead? I will ask you now to look a little bit further down the road in terms of adoption. I mentioned fleets earlier, right? We have to get some kind of critical mass in order to have mass adoption, so to speak. It starts with commercial, I assume, and then moves to consumer. But give us a look ahead, if you would.
Yeah. Just to clarify, that question's about autonomy? Or
Could be either one.
Yeah. I think commercial fleets are an interesting aspect to look at just because they often care about things like operational costs that consumers don't really care about. And when you look at electric vehicles, they are typically cheaper to operate, even if they have higher upfront costs. So if I'm operating a large fleet of vehicles, and it's not just about things like taxi services, but think about the garbage disposal trucks that come and take your trash. You can save a lot of money and operate a quieter vehicle that make your neighbors happier by adopting an electrified powertrain. And of course, the other aspect I think that's interesting about fleets is, of course, autonomy. Right. I think Uber and Lyft and all these ride-hailing companies have been very forward and public about their intentions for autonomy, which makes a lot of sense because Uber's current business, roughly 80% of the money they bring in goes to actually just paying drivers. So if you can eliminate the drivers, yes, it kind of changes your structure as a company to being very, investing in, assets like vehicles as opposed to just operating a platform. But there's a potential to lower costs and develop a really intriguing service. And that's why a lot of the focus on self-driving cars isn't always just about giving us a car that can drive from point A to point B in our garage, but allowing us to use an autonomous vehicle as a service, something like a Lyft that Craig and I hailed to arrive here today.
Craig, you mentioned this a moment ago, and that is if the high voltage system were to shut down, right, for whatever reason, and the functionality you lose, we think of the functionality around self-driving vehicles as knowing what's ahead, right, detecting obstacles, avoiding challenges. But there are so many critical functions, right? Thus, the infinitely higher importance of having a redundant system. Right. What are the other functions you think of as being so critical that simply can't go down for an extended period?
Well, yeah, that's a great question. I think there are a number of things, and probably tiers of importance, if you will. If you think about if you're in an autonomous mode, the first thing is your sensors are your eyes and ears, as it were, to what's going on in the environment, right? So even if you're cruising down the highway and there's no traffic immediately around you, if there's a loss, you can't lose track of the fact that you got to find out what's happening 100 yards in front of you,
right,
or next to you or whatever. So making sure you continue to have sensors providing input. The sensors can do no good, though, if there's no computing power to process that input and make decisions and determine what that environment looks like and what actions need to be taken. And then ultimately, the sensors or the actuators, that would act on those actions. And that really comes down to steering, braking, and speed control in general. So if it's acceleration, if you need to accelerate, whatnot. And I think how long that needs to function before you can allow it to back away, I think is going to be a key question in terms of how responsive do drivers need to be to take over the car in the case of a fault. And again, I think different automakers are going to have different expectations. Driver monitoring systems, for instance, are very critical because it tells you how ready is the driver to take over. So that's another aspect of this. And whether that's 10 seconds, 30 seconds, 2 minutes, that time that it will take to get a driver engaged, to get that car navigated through traffic, if you're on a highway or if you're in the city, and over to somewhere that can be safe in terms of stopping the car and saying, okay, something needs to be done. It's not right.
Right.
That period of time, I think we're still figuring that out. And there's a lot of discussion on what does that need to be. But through that whole process, you can't let, you might be able to turn the air conditioning off. You might be able to turn the radio off. Those are loads you can take out. You can't take out your steering. You can't take out your braking. You cannot take out the functionality around autonomous that is controlling the vehicle.
You mentioned discussions that are underway. Clarios has high recognition, especially in the B2B space.
Right.
What are the most interesting conversations you're having right now with partners, with customers, with clients, et cetera, about where we are now and where we're going?
Yeah, that's really interesting. Because I'd say there's really two different types of conversations. One's the conversation that happens in what I call this public space, and it's the panel discussions, it's the workshops around how do we define regulatory requirements, how do we make sure this is done in a way that's as safe as possible. In introduction of the technology doesn't result in something that none of us want, whether that's accidents or whatever. And I think that's a very vigorous dialogue and has a lot of stakeholders. And that's very interesting. The other part that is that maybe a different kind of conversation is what happens with our customers. And we serve virtually every major OEM on the planet, and they all are talking about this. And I would tell you that while they all have ideas and lots of companies have vehicles on the road, I don't think any of them will tell you they have all the solutions worked out. And I think I think Chris would probably have an interesting perspective on what is the real time frame for this type of technology. But I think once you think beyond a fleet that's managed on a precise geographic region or route, and you get beyond that, I think we're a ways off because I think a lot of these questions need to be resolved.
Well, that was served right up to you, Chris.
Yeah.
Greg pretty clearly said, "Oh, you've got a great prediction." So.
Yeah,
please.
And I think one of the common questions that we get from our client base is simply, why aren't there more autonomous vehicles on the road? Right? I mean, a lot of us were promised them. If we think back 5-10 years ago, what we were hearing about autonomous vehicles is that they'd be here right now. But the reality is it's an incredibly challenging problem to solve. There's, of course, the technical aspects, which, as Craig mentioned, can your sensors actually see through things like snow, fog, and all these different conditions, which there have been a lot of really impressive advancements on the sensor side that are required to make that happen. But the other aspect that is particularly challenging is the social aspect of driving, right? Getting essentially a driving robot to understand a lot of the social cues that we pick up when we're driving. So something like, we don't follow all the rules of the road, rolling stop signs, or if you're, if you pull up to a stop sign with someone at the same time, you might flash your brights to say, oh, hey, you go ahead. Getting a computer to understand those types of social cues is very challenging. And we think that's really one of the main reasons that we've seen a lot of these automakers kind of pushing back when they think autonomous vehicles will be commercialized. So to put some numbers on it, I think we're going to continue to see a lot of these expansion of pilots that look at something like, what we call a geofence level 4 application, which is, you allow autonomous vehicle to run in a certain area, maybe it's a few square miles. That's kind of already happening today in some parts of the world. Typically that is supervised with someone like a safety driver behind the wheel. So when we talk about Waymo, and operating in Phoenix or some of the various other pilots. That is what autonomous driving, looks like today, is someone behind the wheel kind of supervising these systems. And so the transition will be kind of over the next few years. We'll start to kind of remove some of those safety drivers, but keep things probably restricted and geofenced, likely for the next decade. But I actually think some of the really exciting things as a consumer that autonomy brings are not necessarily these fully autonomous systems. There are a lot of systems coming out today and over the next year where it allows something like hands-free highway driving, paired with, as Craig mentioned, a driver monitoring system to make sure you're not falling asleep or, reading a book, where you still have to pay attention to the road, but you're not really an active participant. You're just kind of supervising your vehicle's driving. Right. And as a consumer, that's really exciting.
And that's building upon collision avoidance, automatic braking, right? Lane departure warning systems, et cetera.
Exactly, yeah. Autonomy think of it as kind of a scale of capabilities, where when we think about autonomous vehicles, oftentimes our mind might jump to that fully self-driving car. But there's a lot of really exciting stuff that consumers are going to see in between there over the next few years. Yeah,
personally, I loved telling my dad that, self-driving has been around for decades, Bob. Haven't you ever used cruise control? Right, the technology is something we're actually more familiar with than we might understand. Looking ahead to CES 2020, Craig, what is Clarios' vision, your strategy for what you see at CES and what you have planned?
CES is really become a tremendous showcase for automotive technology, and virtually every one of our customers is there in one way or another. And for us, being part of CES is really important. It's an opportunity to get access to decision makers at our customers and really have detailed, in-depth conversations with them about our technology roadmap, trying to create empathy with them on what kind of challenges they have, whether it's about electrification or about autonomy, and really showcase for them what our capabilities are to serve them and be partners for them for battery technology.
This may be a podcast record for us that we have two guests in studio with a combined one trip to CES prior. Craig, you just made your first trip in 2019.
I did.
Initial impressions?
Blown away. It's an amazing event. I've been to auto shows all around the world, and going to CES, I'm not sure exactly what my expectations were, but they were blown away. And I think what's really interesting is that it really does focus on the future, and everything you see is about what's going to be coming 5 years, 7 years, 10 years away or beyond. And I don't mean that to be like it's a pipe dream or it's a wishful thing. I think it's actually very much in tune with where things really are going. But it is sort of like, we know what is today. We already know that. You can go out and see that. I don't need to see what this year's model looks like. But I really want to know what the 2025 model is going to look like. And I think this was a great way of narrowing down that discussion to focus on what's really going to happen in the future. So I was impressed.
Chris, what about you? Your first trip is coming up. I would, of course, say drink plenty of water, wear comfortable shoes. How you plan to approach it?
Yeah, I think those are good points. I've never been to Las Vegas before.
Oh, not just CES, but not Las
Yeah,
Vegas.
I've never been to Las Vegas.
All right, this might be a separate conversation.
All right,
altogether.
but no. So I mean, from my perspective and Lux's perspective, we've sent analysts that cover things like displays, things like wearables in the past. But as Craig mentioned, I mean, I come from the automotive side where we go to auto shows, we go to kind of some of the more things like battery-specific conferences, but it's becoming clear that CES is a place to think about things like autonomy, connectivity. That is not necessarily next year, but as Craig said, 5 years. So certainly looking forward to that as well.
Yeah, and across industries as well. Craig Rigby is Vice President of Technology at Clarios, and Chris Robinson is a Senior Analyst at Lux Research. Gentlemen, thank you both for being with us today.
Thank you.
It was a pleasure. Thank you.